Welcome to day 17 of our journey into the standard template library. Today we are focusing on one of the most powerful and widely used containers, the map. Whether it's an ordered map or an unordered map, this data structure forms the backbone of many real-world applications like indexing, counting, and searching efficiently. We will also explore how key value pairs work using pair and see how maps give us flexibility and speed in storing and retrieving data. Let's dive in. A map in STL is an associative container that stores elements in key value pairs. Each key must be unique and it maps to exactly one value. There are two main types: an ordered map, simply called map, which maintains its elements in sorted order by key; an unordered map, which uses hashing for fast lookups and does not maintain any specific order. Internally, map is implemented using a retrofit tree, giving us logarithmic or log n time complexity for insertions, deletions, and searches. On the other hand, unordered map uses a hash table, giving us average constant time for the same operations. However, in worst case scenarios like hash collisions, it can degrade to n. This makes understanding the internal implementation important when choosing between the two. Let's look at how to declare maps. We can declare an ordered map like std::: map int, string, id to name. Here each integer key maps to a string value, perhaps an ID mapped to a person's name. For faster access, we use std::: unordered map string, int, word count. This would be great for counting word occurrences. Remember, map keeps keys sorted while unordered offers no guaranteed order. Make sure to include the correct headers: map for ordered maps and unordered map for unordered ones. There are multiple ways to insert data into a map. The simplest way is using the subscript operator, m key assigned value. If key does not exist, this creates a new entry. If it does, it updates the existing value. You can also insert using m.insert key, value, or even better, use mplace for efficiency. m.mplace key, value. Why is mplace better? Because it constructs the pair in place, avoiding a copy or more. A key point to remember: maps don't allow duplicate keys. Inserting the same key again will override the existing value. When you access elements using the subscript operator like this, m key, you need to be careful. If the key isn't present, the map will automatically insert it with a default value. That's not always what you want, especially if you are just checking for existence. A safer way is to use m.add key. This throws an exception if the key isn't found, avoiding unintended insertions. The most robust approach, use find. This allows you to check if a key exists before using it. You can traverse a map using a range-based for loop or iterators. Each element in a map is a pair where dot first refers to the key and dot second refers to the value. Here P is a reference to each pair const key, value. You can also destructure the pair directly. This makes your code cleaner and more readable. Here's a side-by-side comparison of map and unordered map. Use map when you need keys sorted or want predictable traversal order. Use unordered map for placing fast insertions and lookups, provided your keys are hashable and you don't care about order. Each element in the map is essentially a pair const key, value. Understanding how pairs work is essential for using maps effectively. You access the components with dot first and dot second. Using structured bindings makes it even easier. This way, your loop variables directly hold the key and value, making code more readable and concise. Maps are mutable. You can modify their contents easily. To remove an element by key, use m.erase key. To clear all element, use m.clear. To check for existence without inserting, use m.find key. It returns an iterator to the key if found or m.end if not. Let's walk through a real-world example counting word frequency. Here each word is read from input and its count is incremented. Why unordered map this time? Because it gives us constant time insertions and lookups, making it perfect for counting, indexing, and grouping data efficiently. There are a few common pitfalls when working with maps. Using M key on a missing key inserts it, sometimes unintentionally. Unordered map does not work well with custom classes or complex types unless you provide a hash function. Iteration order in unordered map is not guaranteed, so never rely on it for ordered output. Be mindful of these quirks when choosing and using map containers. Let's put your knowledge to the test with some practice problems. Count the frequency of each character in a string. Map roll numbers to student names. Count the number of distinct integers in a vector. Store and update the last seen index of elements in an array. These problems will give you hands-on experience with insertion, lookup, and traversal of maps. It's quiz time. Let's see how much you have picked up. What's the difference between using M key and m.add key? Can you map contain duplicate keys? What the average time complexity of an unordered map operation? When does an unordered map degrade to n complexity? These are key questions to assess both your conceptual clarity and practical readiness. To summarize, use map when sorted order of keys matters. Use unordered map when performance is the priority and order does not matter. Understand how to access key value pairs via dot first and dot second, and always be cautious of inserting values silently. It can lead to hard to find bugs. Maps are a core part of STL and mastering them opens doors to writing clean, efficient code in C++. Great job, see you in the next session.